Hello everyone. To find the unique element in an array where every other element appears twice, we use the classic XOR trick. The logic is very simple. A XOR A is 0 and A XOR 0 is A. Now consider the array 2, 3, 5, 3, 2. If we XOR all elements, 2 XORed with 3, XORed with 5, XORed with 3, XORed with 2, we can rearrange it. That is 2 XORed with 2, XORed with 3 XORed with 3, which is XORed with 5. Now apply the properties. 2 XORed with 2 and 3 XORed with 3 results with 0. So the expression becomes 0 XORed with 0 XORed with 5, which is nothing but 5. So final result is nothing but 5, which is our desired unique element. This works because all duplicate elements cancel out, leaving only the number that appears once. Consider this code. At first, let me check if there are any errors here. No errors, so we'll go ahead with debugging. Here, area is an assembler directive which defines a section of memory. This is nothing but name given to that section of memory. Code informs that this section of memory contains instructions. Read only because this information should not be manipulated during runtime. Entry indicates where exactly execution starts. Start, loop, stop are nothing but labels, and as soon as entry assembler directive is encountered, assembler knows the very first label after entry is the location where execution starts. End indicates the end of source file. The very first instruction will load the address associated with the label array into the register R0, and this array is associated with our array of 32-bit numbers. I'm specifying its 32-bit numbers because I have written DCD here. This array consists of only one unique element. All others have their copies. Now let me go ahead and check what exact address is associated with the label array. Okay, 28. So I'll go to the memory window. Next, R1 is the counter which has the value 5 stored in it because we have 5 elements here. R2 is initialized with the value 0. At first, we are comparing if R1 is already 0. The answer is no, but if that was the case, we would branch to the infinite loop. In our case, this condition is false. How do you know this condition is false? Before executing the branch instruction here, EQ condition is checked. That is, the Z flag is checked. If Z was previously set as 1, this condition would be true and branch would happen to this particular loop. Now, because that is not the case, this instruction will be executed. And what happens in this instruction? We are loading the 32-bit data pointed by the register R0. R0 is pointing at this location. So the value 2 is loaded into register R3. As you can see that happening here. Along with that, one more thing that happens is R0 is incremented by 4. Originally, R0 address was 28 plus 4 will give the result as 2C. Next, what happens is XOR operation. You can see that in this particular step, R2 content and R3 was XOR. So R2 was nothing but 0 and R3 was nothing but 2. So the result is 2. This is because of its property which states A XORed with 0 is A. That's why we are getting the result as 2 in R2. Next, we are performing subtraction to indicate that one task is complete. And we are branching back to the loop. We are checking if all comparisons are done. That is not the case, okay, because Z is still 0. So we'll go here and we'll load the next data, which is 3, into register R3. And R0 is incremented to the next address. While our next step is performing XOR between the result we obtained and the data 3. And the answer for that is nothing but 1. So this particular XOR operation and loading the next value continues until all values in the array are XORed with each other. This continues until Z flag here is set as 1 due to this particular comparison. As you can see, finally Z is 1. So we will be branching to the label stop, which is an infinite loop. And you can see the final result stored in register R2, which is nothing but 5. That's all about this code.